Hang on. Now go ahead and start.
Today we are going to show you how direct sunlight affects an object. Materials we will need are a piece of cardboard, some tape, 2 thermometers, a light stand, and a ruler. First we will record the starting temperature of both the sunny and shady side.
Okay, shady side is 24 degrees Celsius, sunny side is 20 degrees Celsius.
Okay, both about room temperature.
Yes.
Okay.
The cardboard needs to be under the light stand for 5 minutes. Then you will record the temperature on both sides and repeat for 10, 15, and 20 minutes.
Okay.
5 minutes later.
Okay. Well, what's the distance that we're measuring this?
13 centimeters.
Okay.
We'll use
Go ahead and help her.
Okay.
And then I'll need to come back in 5 minutes. I'm going to go ahead and video the other
No,
people
keep it, and then
do the ring stand.
hold this since you don't know what you're doing.
Okay, that's going to be on YouTube now. John not knowing what he's doing. That's not very nice.
Okay. Now how do you get to stay? Stay, friend.
Tighten. You're going the wrong way, maybe.
There you go.
There you go. Okay, so we'll come back 5 minutes later to see what the temperature is on that.
Okay.
Okay? All right?
Hello. All right.
You two need to be quiet.
How do you think the light will affect the radiometer? Personally, I don't think the amount of light will affect how fast it moves.
Okay.
I disagree with that. I think the light will affect how fast the vanes will spin.
It's called a radiometer.
Radiometer.
Okay?
All right.
Just about.
All right. First, in the shade, it doesn't move at all.
We will use 2 light sources. The light source that is the brightest one and light source that isn't as bright as this one.
Okay.
All right. With the brighter light source, it
bright-
moves.
Okay.
Move faster and faster. The closer it gets to the light, the more faster it spins.
Okay. And are you going to do the other one in the other
Yes.
source?
And
Okay.
when
Don't
you
bump
put
their
it- yeah.
thermometers.
When you put it under the less brighter light, it doesn't really spin as much. When you put it closer, it spins a little bit faster. But it's not spinning as much as.
Yeah, that's
as
one's
fast
still
as
spinning, isn't it?
Yeah.
Okay. You want to tell me about it?
All right. What happened between the 3 light sources?
The 3
Talk to me.
Okay. The 3 things that happen, between the light sources is that when the light hits the black vane attracts more heat, which reflects to the white vane, which makes it spin faster. If they were both white, it wouldn't move at all because none of them is faster than the other.
There are 5 energy transformations. What are they?
We learned light changes into heat and then to motion, radiant energy, into thermal energy.
You done?
Yeah.
Okay. Good. All right. You guys. We'll get you in there too.
How fast was the last one?
How many minutes are we supposed to have? 5
Yeah.
or 3? I think we'll do it after this. Okay?
Our question was, how does angles in light affect the power?
First, we took a solar panel and screwed these LEDs on.
Then we put the panel underneath a strong light source. Depending on the angles you hold the panel is how fast the fan spins. When you hold the solar panel at a 30-degree angle, from
Okay, we need this in the picture too.
the fan does not spin as fast as it does when you hold it right under the lamp.
And that would be a 90-degree angle. Go back to the 30. Just about where you had it. That's fine. Okay. And then go back to 90 degrees. Okay. Yeah, you can see the difference. Okay, go ahead and lay those down.
What two kinds of energy are being used here? Correct. Thermal energy to radiant energy. Why do you think the fan does not spin as fast when the solar panel is tilted? The answer is because not all of the light power is shining on the panel. A solar panel changes light into electricity. A solar panel is made up of photovoltaic cells that are connected together. When light is shining on a panel, the photovoltaic cells move, producing an electric current. Depending on how much and how many solar panels there are, is the amount of how many things you can power.
Okay. How do we use this in the real world?
You can put it on like your roof or something, and then the light goes into it from the sun, and it can power your house.
Yeah, and our school has that too, doesn't it?
Yes.
All right. Dee Dee and John? You had a question? Time to go? We'll finish this one. And the others, station 4 and 5, we will finish tomorrow. We're going to finish you guys yet too, I think. How long do you need for yours?
Like, not really.
Okay, well, we'll try. All right. 5 minutes later. Okay.
As you can see, actually you probably can't see, but
What does it say?
it says right at 20 degrees Celsius is the sunny side, and the shady side is at 24.
Okay, so it cooled off a little bit. Okay, and the front side, not much warmer than room temperature?
Nope.
No. It's not a real warm light.
Yeah.
That's true. But we didn't want to break another thermometer. Why don't you tell me real briefly what happened yesterday when you were using the heat lamp instead?
Okay, yesterday we did the same experiment except with the heat lamp. And, well, as you know from the name, it gives off more heat than a regular light bulb. So, for the 5 minutes for the first experiment, we set it under there, and it went up to about 150 degrees Fahrenheit, and that was crazy. But it was, as it went up, it went up so high that the bottom with the alcohol in it exploded, and all of it came out, some on Dee Dee, and as you can see, some on the cardboard.
Okay.
So yeah.
All right, so what's going on here in terms of energy conversions?
Well, first we have electrical energy to power the light bulb, and then the light bulb gives off light and a tiny bit of thermal energy.
Okay, and then the thermal energy is causing what to happen in the alcohol?
Well, it should be increasing the temperature.
Okay, and it's actually causing it to move.
Yeah.
So the thermal energy is actually causing a form of kinetic energy as well. Anything else?
Hi.
All right. And Nicole and, guys, you should be seated. Sit down. There's no reason for you to be up.
Nicole, are you
We go, I am. Sit down, guys. I'm still recording.
Mrs. Ryder, can you film from there?
It
would be easier for us.
I'm not sure I'm going to get to the sea the way we should, but okay. Okay, right now, see, I'm getting Nicole's back. That's why I was thinking filming of over there.
And turn around. Stand there.
Face me. Face me. Thank you. All right, who's speaking first?
Me.
All right, then go over by it.
Hold on, I'm
Okay.
walking.
Okay. Okay.
We're like doing it like a cheesy.
Okay, go for it.
Oh, hi Nicole. I didn't see you there.
Well, maybe because you were walking backwards.
Maybe. So, what you doing?
I was just pondering on this very interesting science question.
What is this very interesting science question?
I was hoping you would ask that. I have been trying to decipher what effects direct sunlight has on the glow toys.
That's a very interesting question, Nicole. What have you found out so far?
Let me explain the experiment to you. I have glow toys in 2 different pouches. One pouch I did not expose to light whatsoever, and the glow toys in the other pouch I exposed to light for 2 to 3 minutes. Then I put them back into the pouch to see how much light the stars produce.
Okay, I understand the experiment now. Can you tell me about the energy transformations?
The bulb on the stand converted electrical energy to radiant energy, and that radiant energy was then stored in the glow toys as chemical potential energy. When the glow toys were placed back into the pouch, that chemical energy was converted into radiant energy.
Cool. What were the results of your experiment?
The glow toys that were under the bulb glowed brighter than the ones that were never exposed to light.
Why did the glow toys that were in the light shine brighter?
Because when the radiant energy from the bulb was exposed to the glow toys, the radiant energy was converted into more chemical potential energy, so they had more energy so they could shine brighter.
Oh, I get it now.
Do you get it now?
Can we look in the pouch? Stick them in the pouch.
Yeah.
Let me zoom in the other one. Let's see these. Okay, they're not glowing. Okay, and these guys. I don't know if we can see that they're glowing.
I don't think so. Like, I can tell, but not the camera.
Okay, yeah, we can tell, but I don't think it's picking up on the camera.
Yeah.